integral number of turns design அது மெயின் அப்ராக்சிமேட் ஏன்னா நீ டிவைட் பண்ணி இப்போ 10^5 நாட் எக்ஸாக்ட்லி 8% அப்ராக்சிமேட்டாக அதிகமாக இருந்தாலும் கம்மியாக வந்தால் ரவுண்ட் ஆஃப் த பேலன்ஸ் ரவுண்ட் ஆஃப் பண்ணிட்டு பண்ணுங்க அதுதான் you can try this problem. So this is the problem based on this concept. What is it? F is equal to BIL sin. So read the question carefully. You have the diagram beside. Based on that, solve it. Current of 2 ampere enters the corner A of the square wave outside 20 centimeter and leaves the opposite corner C. And leaves the opposite corner C. A magnetic field of B that is 0.25 Tesla acts in the direction perpendicular to the plane of the paper. So is it outward or inward? Dots are outward, no? So the magnetic field of 0.25 Tesla is actually in the outward direction as shown in this figure. Find the magnitude and direction of the magnetic forces on the 4 sides of the frame. So the tricky part about this question is, I'll give you a hint. If you observe, it is not a complete, it is not a directly formed square. How is the shape? It has some extensions at the top and the bottom. Are you able to understand? So current is actually not flowing within ABCD. Current is entering A first and then leaving C. So when the current I, which is on the left of A, right, when it is entering the point A, what will happen to it? It gets divided by. So if you directly take the value as I and proceed and solve this problem, you will get wrong answer. The current will become I by 2 and I by 2. Why? Because of Kirchhoff's current law. I hope everybody knows that, no? Kirchhoff's current law. What does it state? The current entering the junction will get divided, no? So how much is the value going to be across AD? In AD, will the current flow from A to D or D to A? A to D. What about AB? It will flow from AB of what magnitude? I by 2, no? So what? Convert whatever I told into a diagram and then proceed. You can first draw the diagram. So listen, the question says a current of 2 ampere enters at the corner A of a square frame of side 20 centimeter and leaves at the opposite corner C. A magnetic field of B, which is of the magnitude 0.25 Tesla, acts in a direction perpendicular to the plane of the paper as shown in the figure. So this is the plane of the paper. It acts perpendicular. It is in this direction. Right. Having said that, Our job is to find the magnitude and direction of the magnetic forces on four sides of the conductor, right? So when you need to calculate the magnetic force, the formula is going to be B into I into L sine theta. So all that we need to know is, so this is with respect to magnitude, and for direction, we are going to use Fleming's left-hand rule, right? We're going to use the Fleming's left-hand rule. The question is, whenever you need to use any mathematical expression, you need to know what data is required for you. Here, what are all the 3 points that you need? Actually, 4 points. You need to know the magnetic field. You need to know the current through the conductor. You need to know the length of the conductor and the angle between current carrying conductor and magnetic field. In this problem, everything is known, but one data is to be found by us. That is, if you see the value of current across AD and AB is not going to be I, because I is on the left of A. So as the current is entering this junction, current gets divided into two equal parts, I by 2 and I by 2. I could directly tell it will get divided into equal parts is because it's a square. Right. So I by 2 and I by 2. So the same I by 2 will continue from D to C, and this I by 2 will continue from B to C. So that this I by 2 and this I by 2 will get added so that you are getting back the original current I. Makes sense? Right. So what is the question? Magnitude and direction of magnetic force on four sides of the conductor. They didn't ask individual values. So for me to calculate FAB, yeah, okay, I'll take FAB, this side. So for FAB, what should I write? Magnetic field into current in AB, length of AB into sine theta. Makes sense? So what is the magnetic field? I didn't write BAB because magnetic field is same for every conductor. So what is BAB? Oh, sorry, magnetic field. It is 0.25, which is going to be 1 by 4 into what is the current that is flowing across AB? I by 2. And what is going to be length of it? So I is 2 ampere, by the way. So it should be 10 into 10 power minus 2 into sine of how much should the angle be? 90. This is in Y direction. Magnetic field is in Z direction. Oh, it is each side, no? Okay. So it will be 20 into 10 power minus 2. Correct. So I is 2, remember. So I is 2, when you substitute it here, you will get it as 1. So 4 will cancel this 25 times. Sine 90 is 1. Right? I by 2 is going to be 1. So answer will be 5 into 10 power minus 2 Newton. I hope it makes sense. So 5 into 10 power minus 2 Newton, but what is going to be the direction? For that, use the Fleming's left-hand rule. Forefinger in the direction of field. Central finger in the direction of current. Extend the thumb. This is the direction. So this is the direction of force. Coming from the beginning, magnetic field is determined by the forefinger. Forefinger is out of the plane. Then extend the central finger. Adjust it. So this is the direction in which the current is flowing across AB. Extend the thumb. This will be the direction. So it is actually experiencing a force in the leftward direction. Clear with this? So just to put it simple, the magnitude for everything will be the same because all these values are same. So from this, I can conclude FBC is equal to FDC is equal to FAD is equal to how much? 5 into 10 power minus 2 Newton only, but the only difference will come in terms of the direction of force. So can you tell me what is the direction of force experienced by AD? Forefinger, central finger. So turn it like this and extend the thumb. It is experiencing a force downward. So what about this conductor? Forefinger out, central finger adjusted in the direction of current. I'm talking about DC. And extend the thumb. Thumb is going to be towards us. So this is direction of force. What about this one? If this is downward, this will also be downward. So AB and DC are experiencing leftward force. AD and BC are experiencing downward force. Clear with that? Yeah. Just make a quick note of it. Same. Rectangle, it will be different. I itself it will change. Correct. So two combinations will be the same. Parallel are the same. Shall I proceed? So 5 into 10 power minus 2 Newton, it is 0.05. So let's validate if this is what we found. AB and DC towards left, is that what we wrote? Look, check your diagram, right? And AD and BC down. Right. So we'll do the next set of problem, that is the force between two parallel current carrying conductors. So whenever the concept of two parallel current carrying conductors come into picture, first thing is you will not be able to calculate the force directly. What will you rather be able to calculate? You'll only be able to calculate the force per unit length. So force per unit length is given by the formula mu naught I1 I2 divided by 2 pi r, where r is the distance of separation between the conductors. So if this is I1 and if this is I2, the distance of separation between them, if it is going to be d, sorry, if it is going to be r according to this formula, right? Then it will be mu naught times I1 I2 divided by 2 pi r. But what is it? It is not force. It is the force per unit length. So you need to be very careful. If they ask, whenever there is a question based on parallel current carrying conductors, if they ask you a question based on force, then the important point that you need to, the important point they need to give you is what is the length that is being considered on that conductor. Because both will be long wires only. Rather, what you will be able to do, you will be able to calculate the force only on a small portion. So for that, the pattern is going to be, first you will actually calculate the force per unit length only. Observe these two formulas are same. You will actually calculate force per unit length only. Whatever length they ask you know on which the force is to be calculated, you need to multiply that with that value. That will give you the total force acting on that small length. Is the point clear? Right. And one more thing I've already given you. If the currents are flowing in the same direction, they attract or repel. If you have two parallel current carrying conductors, current flowing in the same direction will attract. I told you it is different compared to charges. Remember the exact opposite. Like charges repel. No. So if the currents are flowing in the same direction, they attract. It is a reverse scenario. Is the point clear? So if the currents are flowing in same direction, they attract. I'm telling you again, questions based on this concept will be asked. Right? So you need to be careful. Same direction, attract. Opposite direction, they repel. Is the point clear? So having said that, shall we get started with the problems? Try this out. So write down the data, if possible, draw a simple diagram and then try to proceed. Can you tell me the answer for the last statement? Yeah. எங்க இருக்கு? Just take it as same direction. See, for the first part, you have nothing to do with direction. Whether the current is flowing in same direction or opposite direction, force per unit length will have same magnitude. Where will the difference come? That is what they have asked in the second part. No, so you need not worry about it. So in the first part, report only the magnitude. So what is the answer? 10 power minus. It's a simple problem, the one-step problem. Minus 7 varadu. Or centimeter. 25 divided by 2.5 into 10 power minus 1. So 10 power minus 7 into 10 power minus 10 power. See, 10 power minus 7 into 10 power minus 10 power 2, 10 power minus 5 into 10. 10 power minus 4 varum. Why are you getting 2? Correct, you are right. It is 2 into 10 power minus. She's right. Yeah. So let's solve this problem. Listen. A current of 5 ampere flows through each of two parallel long wires. There are two parallel long wires. I don't know the directions of current. You can take any direction you want. So here it is 5. Here also it is 5. Right. So the two wires are separated by what distance? They are separated by distance of 2.5. Observe the unit, it is centimeter. Right. Calculate, the question is very clear. Force per unit length of the wire. So force per unit length, use small.
We can't hear you, sir.
Am I audible now?
No, sir, we can't hear you, sir.
Even now?
Sir, it is audible, sir.
It's audible? Yeah, Hariharan, please check once, no? Is it audible to others also?
Oh, yes, sir.
Yes.
Okay. So the force per unit length is what is asked. So small f is going to be equal to mu naught I1 I2 divided by 2 pi into R. So what is mu naught by 2 pi? It is 2 into 10 power minus 7 into I1 into I2. In this case, I1 and I2 both are 5. So it is going to be 25. The whole divided by, what is the value of R? It will be 2.5 into 10 power minus 2. 2.5 will cancel this 10 times, right? So it is going to be 2 into 10 power minus 7 into 10 is 10 power minus 6. So 10 power minus 2 will go to the numerator. So 10 power minus 6 into 10 power 2 is 10 power minus 4 Newton per meter. Be careful with this. It is not Newton, it is Newton per meter. Okay. And what will be the nature of force if both currents flow in the same direction? Obviously, it is going to be attractive. It's going to be attractive. Shall I proceed? You can try this. Yes. So the question says, a long horizontal wire P carries a current of 50 ampere. It is rigidly fixed. It is fixed. So there is a current carrying conductor which carries a current of 50 ampere, which is fixed. Another fine wire Q is placed directly above and parallel to P. So I'll do one thing. I'll change this part. So there is a long wire which is rigidly fixed, which carries a current of 50 ampere, and let me call this conductor as P. There is another wire Q which is placed above and parallel to P, right? The weight of the wire Q is, the weight of this wire is going to act in which direction? Downward. Am I right? So weight of the wire Q is 0.075 Newton per meter. Observe, they didn't give it in Newton. It is Newton per meter, means they have only calculated the weight per unit length. It is not the magnetic force per unit length. It is rather the gravitational force per unit length, because it is weight. So weight will always act in the downward direction. Is that point clear? Now, read this question. This wire carries a current of 25 ampere. What does it do? It carries a current of 25 ampere. Find the position of wire Q from the wire P so that it remains suspended due to the magnetic repulsion. So if they had mentioned, instead of saying magnetic repulsion, had they told with the help of magnetic force also, you should have understood that there should be repulsion. Why? Because the conductor's weight is acting downward. If this Q has to get suspended in the air, then in what direction is the magnetic force per unit length supposed to act? It should act in the direction opposite to this weight. Makes sense? So what force per unit length should this be? This should be the magnetic force per unit length. Now comes an important question. They told that the current flowing through the Q conductor is how much? 25 ampere. But the challenge is they didn't give you the direction, because they are expecting you to find it. How will you do that? Now we know the answer. If currents are going to flow in the same direction, they will attract. Here, what do I want? I want them to repel. Right? So what should be the direction? Did you understand how much of hidden information is there in it? Right? That is why I'm stressing on that point. Questions will be indirectly framed on that. Remember, currents flowing in the same direction attract, currents flowing in opposite directions repel. That is the reason why I had to take it in opposite direction. So it is going to be 25 ampere. Makes sense? Now, what is our job? Find the position of the wire from P. So they are asking what is the distance of separation between them. That's it. No? Also indicate the direction of current in Q with respect to P. Direction of current in Q with respect to P will be opposite. So here they didn't mention that the current 50 ampere is flowing only from left to right. Only challenge is, if you take it from left to right, current here should be from right to left. That is. So what should be the answer you'll report for the second one? They should be in opposite direction. So the first part, I think it is easy. No? What is F? Mu naught I1, I2 divided by 2 pi R. So what is mu naught by 2 pi? What is the value of I1 and I2? 25, 50. So 25 to 50 is 1250. Right? Correct, no? 125, yeah, 1250, the whole divided by what is the distance of separation? That's what we need to find. Now tell me one thing. This force per unit length, small f, should be equal to which value? This small f should be equal to 0.075. Only then the forces will get nullified. Right? So 2 into 10 power minus 7 into 1250 divided by R is equal to 0.075. I can write it as 75 into 10 power minus 3. Am I right? So 2 into 1250 is 2500. So 2500 into 10 power minus 7 divided by R is equal to 75 into 10 power minus 3. So 2 zeros are gone, you will have a 5 here. So 10 power minus 7 will become 10 power 5 after these 2 zeros get cancelled. So 25 will cancel the 75 3 times. So what is going to be the value of R? R will be equal to 3 into 10 power minus 3 into this will come this side as 10 power 5. So it should be 300 centimeter. No, 300. It should be 300 meter. Everything is in SI unit only, no? Mr. 300 meter is very high vacuum. Correction. So R will go to the other side. So R will be equal to 1 by 3 into 10 power minus 3 into you have a 10 power minus 5 here. This 10 power minus 5 will remain here itself. R will go this side, 3 into 10 power minus 3 will come this side. So 1 by 3 is 0.33 into 10 power minus 2 meter. So how much is it going to be? So this is going to be the answer, 0.33 into 10 power minus 2 meter. Correct? Yeah. Force by length எடுத்திருக்கேன். This is the formula for force by length only. அதனால தான் small f போட்டிருக்கேன். I told you when I explained the formula itself, no. You're clear with this? So it is 0.33 into 10 power minus 2 or 3.3 into 10 power minus 3, which will actually be 3.3 millimeter. I hope it is clear, right? So we'll quickly proceed to the next concept, that is torque. You can just make a quick note of the formula. Did you all finish writing it? Okay. So we'll see some problems that are based on torques on current carrying loops, right? So torque on a current carrying loop, which is placed in magnetic field, is given by the expression NIBA sin theta, where capital N represents the number of turns, I is the current flowing through the conductor, B is the magnetic field, A is the area, sine theta. Theta is the angle between areal vector and magnetic field. So theta is the angle between areal vector and magnetic field. Now, this n into I into A can be replaced with a quantity called as small m, which is known as magnetic dipole moment, right? And B is going to be B only. So mb sine theta. In this case, theta is going to be the angle between magnetic dipole moment and the magnetic field. Okay. So this is what is given here. Small m is equal to n into I into A. How are you going to write it in the vector form? The same torque in the vector form can be written as m vector cross B vector. Okay. So current I is going to be in ampere, area is in meter square, field is going to be in Tesla, torque is going to be in terms of Newton meter, and the magnetic moment is going to be in terms of ampere meter square. Okay. Now listen. So based on the torque concept, observe the maximum torque acting on a coil of effective area. So torque maximum is equal to how much? 0. Sorry. It is 4 into 10 power minus 8 Newton meter on an effective area of 0.04 meter square. When how much current is flowing in it? When a current of 100 microampere, that is 100 into 10 power minus 6 ampere is flowing in it. Find the magnetic induction in which it is kept. Magnetic induction is they're asking you what is the value of B. So the value of B is what is expected. So the formula is same. Torque is equal to mb sine theta, but in this case, there is a keyword with which you need to do something. They use the word maximum. So remember, torque can be maximum when the value of theta is equal to 90. Why is it so? Because sine 90 is going to be 1. So the maximum torque in this case is produced when the value of theta is 90. So that is the hidden information here, right? So when theta is equal to 90, what is that you're going to have? You're only going to have mb, right? Since current is given acting on a coil of effective area. So I'm assuming that this coil has only one turn. Generally, they should mention it as loop. Okay. So M I can write it as NIA into B is B only, but the number of turns here, since I didn't mention it, I'll take it as 1 itself. So this is going to be equal to IA into B. Am I clear with this step? So all that I did is I applied the formula MB sin theta, but because of the word maximum, I understood that theta value should be 90. So I changed this M to NIA because in the problem, I and A are given instead of the magnetic dipole moment directly. Okay. So this M, I wrote it as NIA, but the number of turns is not mentioned. So I'm assuming actually they should have mentioned this as loop. If the coil has only one turn, it is called as a loop. Generally, if they use the word coil, they should mention the number of turns. Okay. So here I took the number of turns to be 1. So what is that you're going to have? I into A into B. So this I into A into B should be equal to how much? So this I into what is the value of A? 0.04 into what is the value of B? That is what we need to find. I think current is also given, no? So 100 into 10 power minus 6 is going to be 10 power minus 4. So 10 power minus 4 into 0.04 into B is going to be equal to how much value? It is going to be 4 into 10 power minus 8. So this 0.04 will cancel this 4 how much times? How many times? 100 times. This will cancel this 10 power 2 times. So 10 power 2 into 10 power minus 8 is 10 power minus 6. 10 power minus 4 into B. So B will be equal to 10 power minus 6 divided by 10 power minus 4. So answer will be 10 power minus 2 Tesla. So this is the magnetic induction. Is it clear? Shall I proceed? See here, they given it as 10 power minus 2. You're able to see the symbol WB. It is called as Weber, WEBER. Tesla can also be written as WB by meter square. We'll be learning about this in the 6th chapter. So if at all you see it somewhere, don't get scared. Weber per meter square is also Tesla. Weber is the unit used for magnetic flux. Weber is a unit used for magnetic flux. Okay. Can you do this quickly? So the question is, calculate the torque on a 100-turn rectangular coil. N is equal to 100-turn rectangular coil of length 40 centimeter and breadth, which is going to be 20 centimeter, carrying a current of 10 ampere when placed, making an angle of 60 degree with the magnetic field. Right, 60 degree with the magnetic field of value 3 Tesla. This is where we need to be careful. Listen to this. Listen to this. If this is how the coil is, okay, let's say this is a rectangular coil. If this is how the coil is, then the aerial vector is going to be in this direction. Aerial vector is always perpendicular to the coil. It is always perpendicular to the surface. Now, if you observe in this question, what they have mentioned is calculate the torque which is acting on a coil which has 100 turn, length and breadth, carrying a current of 10 ampere. This is where we need to understand. When placed, making an angle of theta is equal to 60 degree with the magnetic field. Meaning, if this is the direction of magnetic field, okay, if this is the direction of magnetic field, this coil is making an angle 60 degrees like this. Are you able to visualize? So the coil is making an angle 60 degree with respect to whom? Means this angle is going to be 60. Right? So just for people who are online, if there is a magnetic field, this coil is making an angle 60 like this. So when you visualize it, the angle between the magnetic field and the coil, this finger is there, no, this is 60. But what is the direction of aerial vector? Can you give me a pen? But what is the direction of aerial vector? Aerial vector is like this. Aerial vector is perpendicular to the surface. Okay, aerial vector is perpendicular to the surface. Magnetic field is like this. So the angle between the magnetic field and this coil is 60. This angle is 60. So when it is like this, this angle is 60. But what is the angle we need to take into consideration? The angle between the magnetic field and the aerial vector. So in this question, if you take theta is equal to 60, you will get a wrong answer. You should take 30. So here, theta is actually 30 degrees. This is one common mistake that happens. Okay. So just to simplify, no, make a note of this. The idea is, right, the idea or the keyword, whatever you call it, no, in a question, if they have given you the angle between coil and magnetic field, take theta is equal to 90 minus angle. Did you understand why? Whereas if the angle is given between, M vector or A vector and B vector, then what will you take? Take theta as it is. Is that point clear? Take theta as it is. So having said this, what will be the answer in this problem? Torque is equal to NIBA sin theta. N is going to be 100. I is 10 B is going to be 3. And what is the area? Length into breadth is going to be 1200 into 10 power minus 4 into sine, I should take 30. So sine 30 is half. So this will become 10 power 4. Basically 100 into 10 into 10 power minus 4 can get cancelled. Oh, it is not 30. Okay, I took it as 30. It is 800 into, correction here, it is 40 into 20, which is going to be 800. 800 into 10 power minus 4. Why 10 power minus 4? Because this is 10 power minus 2, this is 10 power minus 10 power minus 4. So 100 into 10 is 1000. It is coming only as 10 power 3 here. Okay, then I'll come again. Correction, guys. I'll come again. Listen. Correction. So n is going to be 100, I is 10, B is 3, area is going to be 40 into 20, which is 800 into 10 power minus 4, because both are in centimeter, into sine of how much is the angle? It's going to be 30. Right. So this will be how much? 1000 into 10 power minus 4. So actually I can borrow 1 0 from here. I can actually take 1 0 from here and combine it with this. So that 100 into 10 will be 10 power 3. 10 power 3 into this 1 0 will become 10 power 4. So 10 power 4 into 10 power minus 4 will get cancelled. So 80 into 3 is 240 into sine 30 is going to be half, which is going to be 120. So 120 what? 120 Newton meter. Is the point clear? Let me check the answer once. 120. Clearer? Shall I proceed? Is there doubt? In a doubt area. No doubt. 40 into 20. Length into breadth. 40 into 800 into 10 power minus 4. Shall I proceed? Torque, I hope you understood. No? So the last set of problems that we have is this one. There's one troublesome topic. I'll help you with this. Okay. So now we'll deal with some problems that are based on galvanometer. So when we talk about the moving coil galvanometer and its sensitivity, these are all the formulae that are used. First one is, in a moving coil galvanometer, there is something called as, okay, if you want to find the value of current. So current is given by the expression K divided by N by A into alpha, where alpha is going to be the number of divisions the pointer is going to turn. Right. If they ask you about deflection, alpha will be equal to just the reciprocal of this, NBA divided by K into I. Clear with that? Now, if you make this as alpha by I, if alpha by I is there, it is going to be NBA divided by K. This alpha by I has a name called as current sensitivity. So alpha by I is going to be equal to NBA divided by K, which is also called as current sensitivity. So the reciprocal of current sensitivity is called as figure of merit, which is I divided by alpha, which is going to be K divided by NBA. Am I clear with this? Right. And lastly, what you have is voltage sensitivity. Voltage sensitivity is basically current sensitivity divided by resistance. Because if you observe, alpha by I is going to be current sensitivity divided by resistance will give you voltage sensitivity. Am I clear with this? So basically, these two are also not needed. Only the third and fourth, only 2, 3, 4 are going to be needed. Actually, these two can be derived from them. So just to put it simple, how did we get these values? We equated NIBA to what value? We equated NIBA to K alpha. NIBA is what? Torque. K alpha is also torque. Right? So based on this only, they derived all these formula. I is equal to K divided by NBA into alpha. Makes sense? Similarly, alpha is equal to NBA divided by K into I. That's what is given here. So all that you need to remember is this one. NIBA should be equal to K alpha. From that, you can manipulate anything and get it. Okay, if at all you forget. Am I clear with this? Okay. Now, so having said this, let's try to solve the first problem. A rectangular coil of area, 5 into 10 power minus 4 meters square and 60 turns. So area is going to be 5 into 10 power minus 4 meters square, and the number of turns is going to be 60, is pivoted about one of its vertical sides. The coil is in a radial horizontal field. Whenever they use the word radial field, what should come to your mind? The value of theta is always 90. That is the angle between M vector and B vector will be 90, right? And what is the value of the magnetic field that is displaced in? It is 90. This capital G stands for Gauss. Gauss is the CGS unit of Tesla. Sorry, CGS unit of magnetic field. Tesla is the SI unit of magnetic field. Gauss is the CGS unit of magnetic field. So it is going to be 90 G, or it is 90 into 10 power minus 4 Tesla. Is the point clear? So 1 Gauss is 10 power minus 4 Tesla. Okay. So what is the torsional constant of the hair springs? So K is equal to how much? If the current flowing through the coil is going to be 0.2 milliampere or 0.2 into 10 power minus 3 ampere, produces an angular deflection of 18 degrees. You have everything available. I told you there is only one formula. You need to equate two equations. You need to equate two expressions. Based on that, have the unknown on left hand side, take all the known quantities to right, and then solve it. So what should be the answer? I told you, what is it? All that you need to do is NIBA is equal to K alpha. So N is how much? 60. I is how much? 0.2 into 10 power minus 3. What is the value of B? 90 into 10 power minus 4. Into what is the value of A? 5 into 10 power minus 4 is equal to K is what we need to find, and the angle is going to be 18 degrees. So since 18 is there, cancel this 18 with 95 times. 60 into 0.2 is going to be 12. 12 into 5 is 60. 60 into 5 is 30. Sorry, 300. 300 into 10 power minus 3 into 10 power minus 8. It is 10 power minus 11. Is what is this? K. Or it can also be 3 into 10 power minus 9. How much will we get? It will be Newton meter per degree. Why Newton meter? Because that is torque by alpha. Alpha is measured in degree in this case. It's not given in terms of division. So the torsional constant here is measured as 3 into 10 power minus 9 Newton meter per degree. Make sense? Clear? So whenever there is this kind of a problem, what is it you need to remember? Can you please tell me again? I've repeated multiple times. What is the only expression you need to remember? NIBA is equal to K alpha. That's it. You should know what each term represents. N stands for number of turns. I stands for current. B stands for A stands for area. K stands for torsional constant. Alpha stands for the angle. The alpha value can either be given in terms of divisions or degree. In this problem, it is given in terms of division. Sorry, degree. That is why I directly wrote it. I didn't convert it to divisions. That is why when I wrote the answer also, I wrote it as Newton meter per degree. I didn't write it as division. Be careful with that. Suppose in the problem, had they given you it in terms of division, it will be Newton meter per division. Be careful with that. Because division and degree are related again. Can you do this quickly? So this I'm not going to do, I'm only going to show you the answer. Just read the question quickly in a minute. Take the data, solve it and tell me. Look at the unit of the torsional constant given in this problem. It is given in terms of Newton meter per radian per rad. It is per radian. The coil deflects through an angle of 0.2 radian when a current of 2 microampere is passed through. Find the number of turns in the coil. Same. NIBA is equal to K alpha. N is what you need to find. I is how much? 2 into 10 power minus 6. What is the value of B? Weber per meter square is the same as Tesla. So it's a SI unit itself. 2.5 into 10 power minus 2. Total over the 2 into 10 power minus 6 into 2.5 into 10 power minus 2. You should get 5 into 10 power minus 8. அப்படியே மைண்ட்லயே பண்ணுங்கடா புரியுதா நான் சொல்றது. So if you multiply current with magnetic field, how much are you getting? Current 2 into 10 power minus 6. Magnetic field எவ்வளோ? 2.5 into 10 power minus 2. 2.5 into 2 is how much? 5. 10 power minus 6 into 10 power minus 2 is 10 power minus 8. So 5 into 10 power minus 8 into area எவ்வளோ? 10 into 10 power minus 4 centimeter square. No. அப்போ எவ்வளோ வருது? 5. So 10 into 10 power minus 2 is 10 power minus 4 is 10 power minus 3. So you'll have 5 into 10 power minus 11. Irka. Left hand side should be n into 5 into 10 power minus 11 is equal to K eவ்வளோ? 1.5. Number of turns, sir? அதான் எவ்வளோ ஆன்சர்? What much is it? So it is basically NIBA is equal to K alpha. So N is what we need to find. N into current into B is going to give us 5 into 10 power minus 8 into area is how much? 10 into 10 power minus 4. What is the torsional constant? 3 by 2 into 10 power minus 8. Correct? 3 by 2 into 10 power minus 8 only, no? Into how much is the radian? 2 into 10 power minus 1. So 10 power minus 8, 10 power minus 8 gone. 2 and 2 are gone. So N will be equal to how much? 3 divided by 5 into 10 power is minus 3. It will go to that side as 10 power 3. So 3 divided by 5 is 0.6. So 0.6 into 10 power 3 should give you 600. That's the number of turns. How many of you got it? 0.6 turns varadu. That would be 600. I don't have the answer, but I hope you understood. Answer 600 turns is right. Clear. So there is one more set of problem that we need to do, that is conversion of a Galvan meter to voltmeter and ammeter. Okay, those set of problems will start tomorrow. So for the first half an hour, I'll do those problems. Next half an hour, I'll start off with the 5th chapter, that is magnetism and its method. That's a very small chapter. Going forward, each chapter will maximum take 3 to 4 classes. Okay. So any other questions? Five into 10 power minus 8. I into 8. I is 2 into 10 power minus 6. B I into B, sorry. I into B. Clear, guys? Okay.
Yes, sir.
Okay, then we'll wind up. Right? The remaining problems we'll do tomorrow.
Thank you, sir.
Thank you, sir.
Thank you, sir.